this thing. It keeps crashing and not recording. I'm not going to record the lecture again. I'll splice these together, I guess. Okay. Good? Question of day one. This is a specification. Your job in the question of the day and everything else and the labs and so on, this is the Bible you have to satisfy. This is the statement of what the problem is. It tells you it takes an integer W, there's the value passed as a formal parameter. That integer represents the weight of an object in grams and returns the weight of that object expressed in ounces. That's all it has to do. So what does that look like? Well, you already know, you should already know that a kilogram is 2.2 pounds, rough estimate. By definition, a gram is simply 1/1000th of a kilogram, and an ounce is 1/16th of a pound. So if you just think about learning these conversions, I'm going to take grams, convert it to kilograms, convert that to pounds, and divide it by 16, or multiply it by 16. This is the function signature you've been given. The simple solution simply takes the W as a stand-in for the weight in grams, divided it by 1,000 gives me the weight in kilograms, multiplying that by 2.2 gives me the weights in pounds, and multiplying that by 16 gives me the weight in ounces. So this is what I had in mind. When I run it, I get that 120 grams is roughly 4.2 ounces, or a quarter pound. In fact, if you're in Europe and you want a little bit of deli meat, you say, I want 100 grams of deli meat. That's just under a quarter pound. That's sort of conversion that you live with if you go back and forth a lot. Now, that said, conversions often introduce precision errors. So this conversion, 2.2 times 16 divided by 1,000, is about 0.0352, about. The generally accepted constant is this. So some of you, very cleverly, looked up the gram to ounces conversion factor, and you got this, and you used this to perform exactly one multiplication. So you did return W times this constant. Some of you got the constant wrong. You were off by a few decimal. In my code, that part that says do not touch here, that's just to give you an idea of whether you're passing the simple test cases. For numbers that are floating point, I usually give a range, so that within a range you're close enough. But for conversion problems, it's hard because nobody really agrees on the constant, and so a lot of you are off by a few decimal points, and you wrote, my code is right, but it doesn't, the test says it's wrong. And your code is like, 300,000th away from what I said it should be. That's okay, because we know that there are precision problems in here. But by and large, most of the code that we're going to do in class is not going to rely on floating point precision, and so this will be the last time you should see effects like that. But if you do see them again, just ask on Piazza. Questions about question of day one? Okay. Let's proceed with where we were. We had seen strings and tuples. Today I'm going to introduce lists. I'm going to introduce lists for the sign function. A list is exactly like a tuple, except tuples use the rounded parentheses, and lists use the square brackets. So that is the only difference in syntax, almost the only difference in syntax that you have to worry about. So here is a version of that first tuple I showed you, except this is a list. Here's a version of that second tuple I showed you, except this is a list. And so far they look just the same, except that one is rounded and one is squared. I can have an empty list of 0 elements, just like I had the empty tuple of 0 elements. All the same. I can have a one-element list that contains a list of one element. So I have a list which is bound by the outer brackets, and it contains one element which is itself a list that contains one value. And here we start to see a deviation from tuples and lists, because a tuple of one element has what? It has a one element in round parens. What else does it need? It needs a comma. Every tuple of more than 0 elements has a comma. You'll notice that I just said this inner element is a list of one element, and there's no comma. So why is there no comma? Well, there's no comma because there's no alternative meaning for this string. Here, this looks like an algebraic grouping of a number, and this looks like a tuple of one element. But this can only be a list of one element, because we don't allow square brackets for grouping, algebraic grouping in Python. All parens and algebraic expressions are rounded parens. So because the symbol has multiple meanings, here there's no conflict in the meaning, and we can actually just treat it as a singleton list. Unfortunately, going back between lists and tuples, this comma is the one thing people often forget, and that causes your code to break, so keep it in mind. Now the second major difference, this is a syntactic difference, it's not a big difference, it's just an annoying difference that you have to keep in mind. The second major difference between lists and tuples is that lists are mutable structures, while tuples are not. So strings also and tuples, both of those sequence types we've seen before, are so-called immutable. Now this is really important. I guarantee you will make a mistake on the exam or in your homework at some point in time by assuming tuples and strings are mutable. They're not. And so at this point I ask you all to take the CS1 pledge and repeat after me. Lists are mutable, strings and tuples are immutable. Lists are mutable, strings and tuples are, yeah, I'm going to do better. Lists are mutable, strings and tuples are immutable. One more time. Lists are mutable, strings and tuples are immutable. Remember that, because you will screw it up. What does it mean? Well, what it means, and we'll get to it in a minute, what it means is that if I have a list of 10 elements, I can go in and cut out some of those elements. I have a list that's shorter. Or I can go into my list of 10 elements and replace elements 5, 6, and 7 with new values. And my list will now be different. In a sense, lists function a lot like arrays, which you might have seen in other languages, except of course they're not uniform type elements. The elements can be anything. So lists can be changed. Tuples, once you create the tuple, once you type that sucker in, it is like that for all time. It's like a constant. You can never change a tuple. You can throw it out and create a new one, but you can't change one that's already existing. Same thing with a string. We have been making new strings all along. We can concatenate two strings to make a new string. We're not changing an existing string. We are creating a new one that it has copies of the old ones spliced together or whatever. So mutability is important. As you have a data structure and your calculation proceeds, changing parts of the data structure changes how the program will run. If you're using tuples, you can't do that. So this is a very big difference and one that you should keep in mind. All right, same operations. I can ask about the length of the string. I can ask about, so this is a string here. I can ask about its length. Now I'm going to show you now new operations for indexing elements of that string. Remember, I can't change a string, but I can extract pieces of it. I can say, what is the 14th element of that string? So here, I have a sequence type, which is a string, and I appended a bracketed expression with the new value. Now that is actually not a list. This is a list when it's typed to Python to be evaluated. When it's appended to a sequence type, it's an indexing expression.